Right, solving simultaneous equations and doing it using the graphical method. So we can solve a pair of linear equations, which are just straight lines, at the same time to find an x and a y value that satisfies both equations. So we're going to go through and have a look at an example, but what we mean is one value for x and one value for y that works for both equations. And we call them simultaneous equations, and they meet at a point of intersection. Let's have a look at these two equations. Y equals x plus 2 and y equals 2x minus 3. We're going to find their point of intersection after we graph them. How can I graph these? Well, let's take this one first of all, x plus 2. Remember the point gradient form of a line is y equals mx plus b, where m is the gradient and b, the constant, is our y-intercept. So the y-intercept is 2. That means it's going to cut through the y-axis here at the value y equals 2. So I can put my first point there. That one's easy. I only need 2 points to graph a line. So if I can work out the second point, I can graph this linear equation, which will be a straight line. I'm going to take the point, well, when x equals 1, what will y equal? All I do is I substitute 1 into the equation. So now y equals 1 plus 2, y equals 3. So in that case, when x equals 1, y will equal 3. I've now got a set of points. 1, 3, x, y. I can plot that. Happens to be right there. Now I've got 2 points, so all I need to do is draw a line that goes through both of those points. That is the equation y equals x plus 2 graphed. Let's do the same thing now for the second line. Once again, the y-intercept is easy to work out. It's this value here. It's the negative 3. So I know that my line is going to cut through the y-axis here at negative 3. So I can plot my first point there. When x equals 1, y will equal, I just substitute x equals 1. I get y equals 2 times 1, which is 2, minus 3 gives me negative 1. So my point, when x equals 1, y equals negative 1. I can plot that point. I've got 2 points now that I can draw a line that runs through. Awesome. We've now plotted or charted those two equations. You'll see there is one point where they intersect. Right? Only one point. It's this one here at the point 5, 7. In other words, if I come across to 5, I go up to 7. The point of intersection is 5, 7. That gives me an x value of 5 and a y value of 7. And we say that that is our solution to those simultaneous equations. The value x equals 5 and y equals 7 satisfies both of those. Now I can check. I can put those values in and make sure that they work. So let's take the point 5, 7 and substitute 7 for the y, 5 for the x. 7 equals 5 plus 2, which is true. Let's now check it in the other equation. Substitute the same values. Substituting 7 for y, 5 for the x. I get 7 equals 10 minus 3, which is also 7, which is true. There you go. So that one coordinate, that one set of x and y values satisfies or makes true both of those equations. We say that is the solution of these two simultaneous equations.